In this video, we are going to be looking at surds. Now, if I ask you, what is the square root of 4? The square root of 4 is 2. If I ask, what's the square root of 100? The square root of 100 is 10, because 10 times 10 is 100. If I ask, what's the square root of 36? The square root of 36 is 6, because 6 times 6 is 36. If I ask, what's the square root of 121? The square root of 121 is 11, because 11 times 11 is 121. Now the numbers 4, 100, 36, 121 are all examples of what we call perfect squares. Do you understand? What if I asked you this? What's the square root of 2? Now the square root of 2, we don't have a whole number for it. It's a very long unending decimal. Same as the square root of 3, and the square root of 5, and the square root of 7, and the square root of 21. The square root of 2, 3, 5, 7, and 21 are not whole numbers. They would give us an unending decimals. So 2, 3, 5, 7, and 21 are not perfect squares. So all these are examples of surds. Do you understand? Now the next thing I would like to teach you is what I call the rules of surd. Rules of surd. Now the first one we are going to be treating is this. Square root of A multiplied by square root of B equals to square root of AB. Does this make sense? Now for example, if I have square root of 2 multiplied by square root of 3, I'll be having equals to square root of 2 times 3, which is equals to square root of 6. Do you understand? If I have square root of 5 times square root of 7, it will be equals to square root of 5 times 7, which will be equals to square root of 35. Does this make sense? Same thing as if I have minus square root of 7 times square root of 3, it will be equals to minus square root of 7 times 3, which will be equals to minus square root of 7 times 3 is 21. Do you understand? Now what if we have something like this? 2 square root 3 times 3 square root 5. Now look at this. We are going to 4 multiply the coefficients. The same way if I have 2x times 3x. Our 4 of us say 2 times 3, that will be 6. X times x, that will be x squared. Do you understand? That's the same thing I'll do here. I'll multiply the coefficients first. 2 times 3, 6. Square root of 3 times 5. Does this make sense? So this will be equals to 6 square root 3 times 5 is what? 15. Do you understand? Let's take one more. If I have minus square root 7 times 3 square root 8. Now remember, multiply the coefficient first. There's an invisible 1 here. So we have minus 1 times 3. That will give us minus 3. Then we have square root of 7 times 8, which will be equals to minus 3 square root 56. Do you understand? Now let's take some questions together. Now let's try to do this. Open the brackets below. We have A minus 3 into bracket square root of 4. Alright, so in this case we have like an invisible 1 here. So this is like minus 3 times 1. That will be minus 3. Then we have square root 4. Do you understand? The same way we could have had minus 3 times x and it will give us minus 3x. That's the same way minus 3 times square root of 4 will give us minus 3 root 4. I hope you know that bracket is the same thing as multiplication. Does this make sense? Let's do B. B, we have minus 2 into bracket 3 square root 5. Now, minus 2 times 3 will give us minus 6. Then we have square root 5. Does this make sense? Let's do C. C, we have 3 square root 3 into bracket root 3. Now watch. Now in this case, we have an invisible 1 here. So we do 3 times 1. 3 times 1 is 3. Then we'll be having square root of 3 times 3. Does this make sense? So this will be equals to 3 roots. 3 times 3 is 9. Now we can go a step further because we know root 9. Root 9 is 3. So this is the same thing as 3 times 3. And this will give us 9. Do you understand? Let me take it again. First, there's an invisible 1 here. We do 3 times 1, 3. Now we have root 3 times root 3. Square root of 3 times 3. 3 times 3 is 9. So we have square root of 9. But 9 is a perfect square. And we know that square root of 9 is 3. So we are left with 3 times 3, which is equals to 9. Does this make sense? Let's take D. Now for D, we have minus 5 square root 7 into bracket minus 2 root 6. Now let's take this. Now remember, first of all, multiply the coefficients. Minus 5 times minus 2. Minus times minus will give us plus. 5 times 2 will give us 10. You know there's an invisible plus. I don't need to write it. So we have square root 7 times square root 6. That will give us square root 7 times 6. This will be equals to 10 root 7 times 6 is 42. And this is our answer. Do you understand? Now let's take the second rule of surd. And that is what I'm going to call the addition rule. Now if I have root A plus root A, that will give me 2 root A. If I have root A plus root B, it's going to give me root A plus root B. Do you understand this? Now this will make sense if you really understand algebra. For example, if I have x plus x, this will give me 2x. But if I have x plus y, I can't add them because they are different entity. So this remains as x plus y. Does this make sense? Now this is like a book plus a book will give me 2 books. Now for this is like a book plus a pencil. It cannot give me 2 books pencil. It's going to be a book and a pencil still. Do you understand? So you can add or subtract entities that are similar, but you cannot add or subtract entities that are not similar. So in this case, we can also have square root A minus square root B will give us square root A minus square root B, because they are different entities within the square root sign. Do you understand? Now I need to separate something very quickly. Now I always view addition and subtraction as not too powerful. It's like you are trying to bring 2 things together. For example, think about it this way. If I've got an iron rod, and let's say I've got another rod which is, let's say, copper, and I'm trying to add these 2 together, so I'm pushing them together until they meet. Now no matter how hard I push them together, they can never fuse together because they are different things. Does that make sense? So this is just like addition and subtraction. You can only bring them together, but they can't enter each other. Does that make sense? That's why when we have 2 different things like x plus y, it can never be xy. No. Because they are 2 different things. You keep pushing them together, they will never fuse together. But multiplication is more powerful. Very powerful. So for multiplication, if I still have these two rods, so let's say we've got these two rods, and then we've got another rod, a different rod. This could be iron, and this can be copper. And I'm trying to multiply. Now, multiplication does not bring them together. What multiplication does is that it's going to melt the iron and melt the copper, and now it can mix them together. Do you understand? So multiplication has the power of mixing together. So it's like now we would have something like this, copper, and then iron. We could have in between copper and then iron. It's like it has mixed them together. Does that make sense? So think about multiplication as more powerful than addition and subtraction. So powerful it can melt even copper and iron. Does that make sense? So if I have, for example, P plus Q, they are different things, so they can't add each other. So we'll still have P plus Q. If you have P minus Q, you are still going to have P minus Q. Does that make sense? The same way if you have square root of P plus square root of Q, it's still going to be square root of P plus square root of Q. But for multiplication, if I have P times Q, it will give me PQ. They would fuse together. Does this make sense? If I have square root of P times square root of Q, it becomes square root of PQ. Do you understand? I hope you do. So let's take a few examples on the addition of surd. Now we've got these questions, but before we treat this question, I need to note that in the last rule we took, I called it addition rule. It actually should have been addition and subtraction rule, because I'm not going to separate them. They follow the same logic. Can we do these questions now? So let's do this. Let's start with A. A, we have square root of 2 plus 3 root 2. Now root 2 plus 3 root 2 will give us 4 root 2. Do you understand? The same way you would have x plus 3x will give you 4x. And in your mind eye, you can think of it like this. We have square root of 2 plus 3 square root of 2. So we have 1, 2, 3. Now if we add them together, how many square root of 2 do you now have? 4 root 2. Does this make sense? Isn't it simple? Let's take B. Now B, we have 5 square root 2 minus 3 root 2. Now you can hear me using square root 2 and root 2 interchangeably. They could be used interchangeably, so don't be confused. Now 5 root 2 minus 3 root 2 would be 5 minus 3 is 2, so I have 2 root 2. And this is my answer. So remember, in primary school, it's just like when you will be told count 5 root 2, and you're like 1, 2, 3, 4, 5. And the teacher tells you, take away 3 root 2. And so you go 1, 2, 3. How many do you have left? 2 root 2. Does this make sense? This is very simple. Let's go to C. So for C, we have 8 root 3 plus 2 root 3 minus 4 root 3. Now you can see they are all root 3, root 3. So we go one step at a time. 8 root 3 plus 2 root 3. 8 plus 2 will give us 10 root 3. And then we now bring minus 4 root 3 down. Does this make sense? So 10 root 3 minus 4 root 3. 10 minus 4 is what? 6. So we have 6 root 3. And this is our answer. Do you understand? Let's do D. D, we have 3 root 5 plus 2 root 3. 3 root 5 plus 2 root 3. Now you can see that what is within the square root sign are different. So we can't add it up. Remember, plus and minus, they are not very powerful. So because we have different things within the square root sign, we can't add it. So our answer will remain 3 root 5 plus 2 root 3. Do you understand this? So let's take E. So we have E. E is 9 root 2 minus 4 root 3 plus 3 root 2 minus 5 root 3. Now remember, when you have this kind of things, we usually say you collect like terms. Can you remember? So root 2 and root 2, you bring them together. Root 3 and root 3, you bring them together. It's like you're just rearranging. Does that make sense? So we are going to be having 9 root 2. So I bring 3 root 2. Now if you look carefully, the sign of 3 root 2 is plus. Do you see? Now because I'm not crossing the equal to sign, I'm just rearranging. I don't change the sign. So I'll still be having plus 3 root 2. Does that make sense? So I pick this. Now remember also, the sign of 4 root 3 is minus. So don't change the sign. Minus 4 root 3. And then I bring 5 root 3. Sign is what? Minus. So I have minus 5 root 3. Do you understand? Now I can add 9 plus 3 is 12. So I have 12 root 2. Minus 4 minus 5 will give me minus 9. So I have minus 9 root 3. Now we have root 2 root 3. We can't add, neither can we subtract it. So this would be our answer. I hope you understand. Is this not simple? So if you have a very good grasp of algebra, this becomes a breeze for you. Let's take F. So we have F. 5 root 2 minus 3 root 3 minus 8 root 2 plus 3 root 3. Remember, collect like terms because we're having root 2 and root 3. So we'll bring root 2 together. We'll bring root 3 together. So we can write 5 root 2. Now the next one we want to take is 8 root 2. But don't forget the sign, minus. So we have minus 8 root 2. Then we bring 3 root 3. But the sign is what? Minus. So we write minus 3 root 3. And then we are left with this. The sign is what? Plus. Plus 3 root 3. Now 5 root 2 minus 8 root 2. 5 minus 8 is what? Minus 3 root 2. Now look at this. Minus 3 plus 3 will give us 0. So it's like we're having 0 root 3, which is equals to 0. Does this make sense? The same way you have minus x plus x will give you 0. Minus 2y plus 2y will give you 0. Minus 15z plus 15z will give you 0. That is our minus 3 root 3 plus 3 root 3 will give you 0. It's like both of them will cancel each other. So we are left with minus 3 root 2. I hope you understand this perfectly well.